May kilala na si Good.
Yep, have at her whenever you're ready.
Okay. Let me share my screen first. Okay.
See lots of untitled folders.
Yeah. Okay.
Ayos. Have at her.
So hello. Welcome to the PhRUG August meetup. In this talk, I'm going to show how to fine tune and deploy LLMs. So in this case, we're going to fine tune Quen 2.5 VL. It's an LLM made by Alibaba. So first, hello, I'm Timart Balaguer. I'm a software engineer here at Narra Labs.
Why are we there?
And yeah, you can call me Ray for short. And then this is our team members here. So this is, for example, this is Super Ken.
Super Ken.
Okay. So for the demo, so for the app, so for the demo app that we're going to use, it's called Recibo. So, wait. So for context, every time that we go here in the office, we have meal reimbursements in Narra. So every end of month, we will send those receipts with the daily breakdown and then the summary. So so that gets quite tedious to process. So that's why I built this app. This is just a demo app, so please excuse some edge cases. Right. So if we go here, see sign out. Let's go in. Yeah, so this is built in Rails 8, and then with the default authentication of Rails. If you sign in, it's using the new implementation of the solid queue, solid cable, and then solid cache. So example, let's go receipts here, and as you can see it has a status of uploaded here, then completed. So it will so using our custom LLMs, so it will process the receipt, and then it will automatically add an amount here. Yeah, that's for the demo app. Next is the overview. So just an overview. First, we're gonna talk about the LLM basics, and then do the fine tuning, and then we're gonna deploy the LLM, and then the demo app also. So and then we're gonna deploy the demo app to Windcam app. So first, the LLM. So in order to understand the fine-tuning stage of LLM, we need to have some context. So first, so sorry, does anyone know what LLM means? You guys use AI. So yes. Nice.
Large language model.
Yeah. So the open here just means that it's open source. So that means that the LLM provider, open source their models, so the weights, and then sometimes they're also open source their data sets. Okay. So in the general overview of LLM, it's just an X-word predictor. So when you input a set a string and input data, it will just convert it to vector representation. That's just a list of numbers, and then it will create this probability table where it will pick the highest, not, it will pick the highest probable token. So for example here, it will pick in at the top probability. So it will not always pick the most probable token because it will be repetitive LLM. So yeah, so that's the high level overview of how LLM works. And then also we can get more context with how LLM is trained. So first, so this is from Andre Karpati here. So he's a very famous AI engineer. He works with Tesla and OpenAI. So so this is his explanation of how LLM is trained. So first, we will collect data from the internet. So we will scrape data and then we extract those data and then clean those extracted data. As an example, we can go here. So this is FineWeb. This is an open source data set from Hugging Face. So Hugging Face is the kind of like GitHub for AIs. So this is the data set that they collect. As you can see here, this is just, I think, articles. And the size is 108 terabytes of data. So that's like the scale of LLMs. And then next is tokenization. So since we already have the data, we tokenize it for easier processing of the text, and then we feed it to a neural network. So in most of the LLMs, they use transformer transformer architecture. So it has a lot of complicated parts, but basically it will create this probability of for each token. So in this example, it has this input token, and then it will create this probability, and then it will pick in this probability table. And then step 4 here is the inference. So inference is just the running of the LLM. That's the pre-training stage. It will create a base model. Sorry. But the thing is, for the base model, it's not very good chat model. So if we have an example with open router here, the model, so base. So if we go here, so we pick Llama. So Llama is one example of an open source LLM. So this is their base model. If you try to have a chat here, what is the capital? Okay, time out.
Yeah, you have API key set up. You probably they probably want you to put an API key in, like Jasper saying, some kind of an account / setup.
Yeah, I'm out of mode.
Unless you throw OLAM on your locally hosted N8N, that's sort of like what I'll probably be doing for next month when I start running an agent through this NCP server, because then it's like a fully self-custody sort of situation. But I didn't get that far.
So I think Open Router has some problems right now, so you can just proceed. But the thing about base model is it will just predict the next word. So if, for example, it is trained in Wikipedia data, So it will, so the output text would be just like Wikipedia. So there's like superscripts. So that's the pre-training stage. So create a base model, and then there's another stage before this LLMs is released. So this is called the post training. So supervised fine tuning stage. So in this stage, LLM providers like OpenAI or Google will train their LLMs to respond to to chat. For example, here um, they will train it to respond to what is 2 plus 2. Then they will add like assistant here. So as a concrete example, we also have here. So this is a sample of the training data that they have. So this is a yeah. So this is the text, this is input text, and this is the output. So what this will do is it will fine tune the base model to have a better conversation with the user. This is another example here. So I think this is a better example. So it has the text, and then this is the prompter. Prompter is the user. Then the assistant is the LLM. So this will train the AI to respond to the user. Yeah. Okay. Next is, so in order for us to get a better, to have a more accurate model, so we can fine tune it even more. So for this demo, I'm gonna fine tune 2.5 BL. So again, this is an open source model made by Alibaba. So first, for the setup, so we need data, then we need the server. It can be your computer. So if you're running an NVIDIA or any AMD laptop or desktop, so you can use that. Then software. Unfortunately, we're not gonna use Ruby for the fine tuning because there's not much support for LLM fine tuning. But there's a library in Ruby for loading LLM. It's called Transformer Ruby. So this can be a base for running LLMs in Ruby, although there's no support yet for fine tuning. As you can see here, maybe one of you can create a support for fine tuning. This is made by the person who made the Ahoy Jam. Very, very famous Rubyist. Yeah, so for the demo, you're gonna use DigitalOcean server. Here, then you can use a GPU droplet. I picked DigitalOcean just because I have a $200 free trial. But if you will run it personally, I will pick RunPod. It's much cheaper. It has a lot more choices of GPUs. For example, here, pods. Here, for example, 5090. So you can get like 0.75 an hour. But anyways, we have the GPU droplet. So you can use DigitalOcean, the AIML ready. Then for this demo, we can only use one GPU. As you can see, it's very expensive. But Yeah, you can use actually you can use a free version free GPU from Google Colab. If you just experiment, you can use a Google Colab. Let's do this again. Okay. So while we're waiting for the droplet to get created, let's explore the code. Wait, sorry. So this is the script that we're going to run. Um, so this is came from a Jupyter notebook. That's why it has this bang symbol. So it will basically run a CLI command. Um, but if you're going to create your own, I recommend to not use this. So just run it directly to the terminal. So yeah, so it will install pip and then it will add the Unsloth library. And then this is just some cleanup code here. And then it will import the libraries here. And then this is our instruction. This is the prompt we're going to train on. And then for the data set, I'm going to use the receipts that I'm sending uh, Narra. This is a sample receipt here. Yeah, so here, and then the annotations. So when fine tuning, we need the input, which is here the image, and then the output, which is the totals here. So I actually use another model to create these annotations. That's a common technique in fine tuning this LLM. So um, technique is to use a stronger model. In our case, it's Claude 4 to create the synthetic data, and then we're gonna feed it to lower parameter model. So this is the annotations. Just calling the Claude models here. So our droplet is created. So let's connect here. Let's just say it's a page. Let's connect. Yes. Okay, so this will connect to the remote server. Okay. Um, okay, so we're now connected to the server. Let's just click git clone the script. Sorry. Large. Open. Okay. And then while it's installing, let's install Jupyter extension. Okay. So it clones the repo. You can see here. Then we can run the fine-tune script here. Might take a while to run, so I'm just gonna go through. Okay, so it will just install the runner. the Python environment on the local, the remote server. Here, let's try to add the kernel, Python, and try this just like Rails console. Uh, call picture. I think there's some issues with the uh, remote server here. But I have a backup, so let's not run it in the DigitalOcean. I think there's some problem with configuration of the server. So let me destroy it first because it's expensive. Okay. Anyway, so let's just run it in the runtime server. So in the runtime server, you can have like different selections of GPUs. In my experience, 1590 is enough to train the Quen 2.5 model. Then let's deploy. Okay, let's see. And we'll move it here. Okay, so now it's running. So we need to connect to the remote server. Then go in the Discord here. So let's connect to the remote host. Okay. Can you does anyone use like remote servers before with the cursor or VS Code? I think we do. Yeah, with the Mac. Yes. Yeah. Let me open like workspace. Okay.
Not me.
For context, our workspace path is the only one that gets saved if you shut down a runtime instance. That's why we're going to move to the workspace path. Then let's install Jupyter. So this is just an extension. While it's installing, let's git clone the repo. Okay. Let's try again. Fine tune script. Window type. Okay, that works. So let's install the required libraries. Um, yeah, so this will install the Unsloth library. So what Unsloth is just a collection of fixes for running the model. And then it also has some default configuration for fine-tuning LLMs. So as you can see, it will download NVIDIA drivers. Unfortunately, it doesn't support M series laptop, so MacBook laptops for now. It will only support like common GPUs like NVIDIA and AMD. Wait, check natin yun. Wait, sorry. I just need to just gonna set up the so Unsloth is now installed. So let's run the full script while exploring the code. Okay, so this code is just a copy of what Unsloth is provided here. So if you go Unsloth, this is the repo. So they will provide a free sample for fine-tuning an LLM here. So these are built by an NVIDIA engineers. So yeah, so he is has really good fixes for the drivers. So as you can see, it has like a better performance for fine tuning compared to the traditional way of fine tuning. Okay, let's see. Let me clear up the. Let's restart the cell first. So let's explore the training script. So first it loads the training data. So again, this is the receipt data. We will split it with the training data and then the validation and the testing data set. And then we're gonna initialize the model. So initialization of model came from Unsloth. Here, as you can see, we're using 22.5 VL. And then we're not gonna load it for V. Yeah, so it will just initialize the model. And then after initialization, we're gonna run a pre-training validation just to confirm that the LLM is working and just to get the baseline. Okay, so let's rerun. Oops. There's like a um yeah, so it will run the validation and then the most important part is the training. So in training, it will just add this configuration. So Hugging Face already provides these functions. The most important one is the number of epochs here, and then the learning rate. Epoch
What is SFT?
supervised fine tuning. So that's what we're going to run. We fine tune the model that's already trained. Let's see what's the error here.
I wonder at this stage if you can just give a little bit of like what you're hoping because you're uploading the receipt data is going to be your training data, right? So
Yes.
like the idea is that it's going to be more successful at identifying the content of the receipts. Is that correct?
Yeah, that's correct. Yeah.
Yeah. Okay. So is the model that was the Velo or whatever it was called, is that an image data? Is that an image model?
Uh, yes. It's trained with image and videos.
Cool.
Wait,
Okay, yun lang.
picture again. I think it's messing up with the order. So let's F to okay. And it's having a problem with the file path here. So let's we try to here find mixer slash uh, put it in the root folder. Um, it should work. Uh, Open the output now. Okay. Um,
Do you see the question from Jasper, Ray? He's asking,
nope.
how do you determine the number of params you're going to use, like epochs, etc. If he recalls correctly, that's going to determine if your model is going to be oversampled or undersampled. That can you comment on that a bit?
Yeah. So for Unsloth, if you use Unsloth, there's actually a good setting for the number of epochs and then the samples. So usually we just leave that as is, the parameters. But as a good practice, as a good measurement, you use epoch here, 3 for a small number of data set. So so right now we are only using like 197 training samples. So usually fine tuning, you use like 1,000 training samples. So if you have more data, you can increase the number of epochs here. And then learning rate, usually for fine tuning, it's around 1e-4 to 2e-4 here. So 2e-4 just means like a really small number. So this will determine um, how many times the um, model will update. Yeah, so basically, if you just getting started, just use the default Unsloth parameters, and then if you have multiple data, you can increase the parameters here. Yep. So our script is now working. So this run the pre-training baseline here, and then it will run training. So in this case, it will run 3 times here. This determined by the number of epochs. And then so this is just for the demo. It was faster. But usually when you fine tune a model, it takes about an hour, depending on the GPU, and then depending on the number of epochs that you run. Um, yeah, so right now we're training in our personal data set, but usually If you want more data, you can go to Hugging Face, for example, here, and then you can get large number of data set in Hugging Face. So for example, see here, sometimes you need to agree to see the data. I think there's some samples that we can use. For example, this one, and then I think I have the receipt. I forgot the name of the data set, but there's multiple data sets here of receipts if you want to take a look at Hugging Face. So let's go back here. So our model is now trained, as you can see here. And then this is the post-training validation. So it will rerun the data set that we have with the validation data and then testing data. Okay. Okay. And so after the validation stage, it will save the model. But what's there here? File.
How much do you usually budget for your fine tuning, Ray? Jasper also made a comment that he's looking at like 10 hours being maybe $40. Does that sound about right to you? What do you usually plan for if you're going to do something like this?
Yeah, that sounds about the ballpark for fine tuning. But you can use smaller servers. For example, in RunPod, you can select um, different servers, much smaller servers, if you're going to fine tune smaller LLMs. For example, if you have like 1 billion parameter model, so you can use as much smaller. In this case, yes, you will need to use like $1 an hour. So for the fastest one, you can use $5 here. But yeah, it will be quite expensive uh, if you will train a large data LLM. So wait,
I
let
think those, I mean, the base models, they cost hundreds of millions of dollars
yeah.
to train. So yeah, you could see fine tuning and that can even like how big is this new data set that you're adding?
200 receipts. So
200
that's
receipts. So
yeah,
that's probably like less than a gigabyte.
yeah, that's correct.
Okay. Yep.
So there's an error here, but actually we need to patch some code provided by Llama CPP. Okay. I know. Problem. Copy this code. TNV contains the Hugging Face token. So let's just copy that. Oh shit. Okay. So I'm just gonna rotate that token later. But uh, don't worry about the token. So let's run again the saving. we need to okay, it's clear. So the problem is we don't have the token for Hugging Face. That's why it's erroring out. But see here, there you go. So it will read the remote remote repository from a Hugging Face, and it will push the training model, the trained model here, and then we're also going to save the GGUF format of the LLM. Now, the GGUF format is for running the LLM for LM Studio or Llama C3P. So this will just save the data here. So we can skip that part. So so the result will be in Hugging Face. So go here and here. So there you go. So you can see it's updated 1 minute ago. So we now have the fine-tuned model in Hugging Face, and then we can try it in our local device. For example, in this case, I already uploaded the, sorry, I already downloaded the fine-tuned model for. So this is an example here. Can add probably another one. So this is coming from the training data set, so it should work. The loading, and then as you can see, it outputs the expected format that we have. Yeah, that's the fine-tuned model here. Again, you can run it locally.
Is the amount right?
Yeah, that's a good question. Let's see.
That one looks okay.
Total here.
All right, is it the same photo for both of them? Jasper's saying you should get it to try and include the currency as well.
Okay.
Yeah, try a different one this time. Jasper, what you're saying about the smaller GPUs being lower accuracy, I don't think that's the case. The place where one of the big things about different GPU specs is the amount of RAM that they carry, and that ends up being how big of data sets they can process at a time. Like in a language model, if you've got like 1 million different words, or sometimes they chunk it up into parts of words, then you're getting into like millions or even billions of possible tokens. And they want to be able to feed all of that into a single pass of the processor. So that's where, like, it's a performance thing, but I don't, from what I know, you're not going to lose accuracy by having weaker hardware. It's just going to take longer to run, and it may end up being like crazy inefficient, and like the amount of extra time it takes to run if your data is the wrong kind of size can be really huge.
Yeah, yeah, that's correct. The size of the GPU doesn't really matter for fine tuning. No, sorry, for the accuracy of the model. It just needs to load the LLM to the VRAM. So if it loads the model, it can fine tune it. So here we have different example. As you can see, we have the dining total here, 245. And then it added the format here. Now Jasper is saying that we include the currency. Unfortunately, I haven't trained it to include the currency, but we can add it in the annotations, actually. Sorry, annotations. There's the data here. It's the JSON format.
Yeah, Jasper, definitely depends on the data set. Accuracy depends on data very, very close.
Yeah, so if you want to include the currency, you can just add it in the training data set and it will output the currency here.
So how many of your 200 receipts did you provide annotations for?
I provided all of them here, but we split the data so that it will only get some subset of data for training.
Yes. So in order to add currency, you need to have more images with different currencies, right? Then yeah, you train it to.
Yeah,
That's right.
if you wanted to properly, if you wanted to be able to properly tell between them, then you'd want to show. I mean, it's possible that the original model is able to pick that up itself, but
Yeah, I think it can.
did you try to do this like on the model? Like, did you try and run this data set through the model before fine tuning?
Yeah,
Okay.
and it has some like hallucinations with the receipts. The thing is, it was run on a general data set, so its accuracy is also, it has an effect on its accuracy for a specific.
Yeah, I think the training logs I saw earlier that the training accuracy was like 70%. So I think that's the ballpark there.
Jasper had a good suggestion for you there, guys. If you throw a dollar sign on all your annotations, you'll get a better, more preferable rate of reimbursement.
Dollars.
In dollars. Let's see. I think the base model can do it, but we can explore it offline. Yeah, so basically right now we have a fine-tuned model that we can deploy. So let's go back here. So we already fine-tuned the model. So let's deploy it with VLLM. Now, VLLM is just a LLM server that is optimized for outputting a large amount of um, data from LLM. So let's try. Sorry. So let's go back to DigitalOcean. Since DigitalOcean has a nice script for running the VLLM server. So let's pick the inference model. So inference just means the outputting of data from the LLM. So usually if you will run it in production, you have a cluster of GPU. So this is the more preferable setup. But as you can see, it's $27 an hour. Yeah. So we're just gonna use the single GPU. So let's see here and create the droplet. Here. So it has this nice script that we can run, and then it will configure the server to run the VLLM server. Yeah. Okay. See. Okay, it's still building. but we can explore the script that DigitalOcean provided. This is their runner here. So it's just a simple script for building server. Here, it will pull to Hugging Face, the fine-tuned model. And then the most important part is the VLLM inference, this one. So this will run the API server that is compatible to OpenAI API. So if you have already gem for OpenAI, it will be compatible to that gem. And then yeah, so it will create a HTTP server, right? Actually, originally I was planning to build it with Camel proxy here. I'm not sure why, but it breaks the droplet. Yeah, so we can demo it another time. So now the droplet is set up. Let's go. Okay, let's see here. Let's reach to the server. Okay, yes. We have this. So we have this script here called run model. So let's just run it. H. So it will set up the server to run VLLM.
Jasper, yeah, I'm in the Philippines. I'm in Batangas City. I'm working a project with Batangas State University. We're going to be one of the first locators into their new KIST Park, Knowledge, Innovation, Science, and Technology. It's a new like PESA zone for domestic use that they're setting up. So we're doing electric vehicle stuff focused on the TOTA sector, electrification of TOTAs. So when you see the data set that I'm working on, that's very along the same lines as that kind of open data for public transportation sort of stuff is the stuff I'm focusing on, especially when it comes to Ruby and web apps. But we also got also got an app on the Play Store that that we're kind of building out for the electrification of TOTAs, really helping them start to digitalize their services.
Okay. Sorry. So so right now we're running the script. So it just needs the Hugging Face model name. Again, this is the fine-tuned model. So we can just copy it here and it will download the model. And it will set up the server. It's starting the server. And it will wait for it to run. Now, the problem with this script is it will build a server that's in HTTP. So it's unsecure. It doesn't have the the API tokens. So I have another script to create those, but we can have it in another time. See here, run model, here, API, and token, API key. So if you add this, it will create an API key for the LLM. So it's just booting up the server. And then, so while it's running, so let's move to the next part, which is Rails 8. See, it's enough. Yeah, so after deployment of the LLM, we basically now have a custom LLM that we can use for chat or like projects. So as you can see here, it's now running. So if you go in the, you get the IP, put IP here, and copy the example. Okay. Yeah, so then let's try to run it. Sample here. As you can see it, it's outputting text. So that means that our server is now working. And it's actually really fast. So yeah, there we go. So that's a remote server. Again, this is not secure because one, it doesn't have the API key and it's in HTTP. So you can use Kamal, actually Kamal proxy to secure it. But yeah, I think maybe next meetup. So yeah, so we have now the API. So next is real estate. So we can now deploy it with real estate. So first, what's new in real estate? First, solid trifecta, solid cache, solid queue, and solid tables. So that's just basically removes the dependency to Redis. So we are now able to run the Rails app without Redis. We can now use SQLite with Rails 8, and then it has Camel as for the deployment. So Camel is just a deployment tool for Rails 8, and it will automatically create the setup the server with Docker. So for the demo, just gonna show the what's new with Rails. We can exit here. Go. Then so again for creating a new Rails app, so it's just the same command Rails new for this case recibo. So I already have the project file, so we can exit that and go back to the Recibo app. So sorry, not Rails, Rails S, and then those. So that's just the same Rails configuration. And then so Rails actually added this new command for authentication. So it will create authentication by default without using other gems like device. So if we search our see the sample here. So it will add decrypt as a dependency. And then what's interesting is it will add the helper for this one. So instead of installing a device, it will create its own helpers here. As you can see, authenticated, require authentication. It's just the same with device. And then for the routes, we have sessions and passwords. So if we go session, okay, need to migrate. We need to clean up the database first. So let's do that. Rails DB. Yeah. And it's also migrate. So as you can see, this is the default Rails um, authentication. So it has the sign-in page and then the forgot password page. So the forgot password. The passwords. This one. This is by default what's included in Rails. Now it doesn't include the sign up flow because it varies between application. So yeah, that's what's new with Rails. We can by default it's already set up the solid cache and solid queue. So if you go in the cable, for example, uh, so it's already set up for production. And then for the database, it has this. So it has different databases for solid, solid trifecta. So this is a solid cache, the queue, and the table. Yeah. So and then let's go back to the main. See. Mm, let me just remove that. And so I'm gonna cheat a little bit. So to build the app. So those, then it's gonna install the migration. And it has already the data, so let me configure it. Let's drop the database for now. Okay.
Ray, you can also do DB setup, and that'll run like the create, the migrate, and the seeds all in one run. And I'm Canadian, Jasper. I've been here since 2015. So this is coming up on my 10th year here.
Right. Got the migration here. So this is the app here, and this is the sign up flow. And I forgot the seed, so let's do that. LCD. And again, there you go. So this is the app. This is running the Rails 8 app, the Rails 8 configuration. And now we can deploy it with Camel. So with Rails 8, it's already bundled with Camel. So we can just use that.
So are you launching the model via Kamal as well?
No, not right now.
Do you think that would be doable?
Yeah, actually, I have a script to run the LLM server with Camel proxy, but it breaks the droplet. So I'll try it offline. But yeah, it's definitely doable with Kamal.
Cool.
So for Kamal, it's just have the you only need one file, which is the deploy commands here. So you need to set up the servers here to update the IP address, and then if you have a job, you also update the host here. And then for the proxy, this is just the domain that you have. And then with Kamal, you need to push it to a registry, so Docker registry here. And then, of course, the registry password here. So that's basically what you need for deploying Kamal. And then if you're running Tailwind and you're using a Mac, you also need the builder. Yeah, the builder here. If you don't, if you remove this, it will not build the assets correctly. So you need to add the builder configuration here. So let's just demo that one. So let's create a new droplet. Droplet here. Go with the closest one. Then that's fine. And then for the storage, I recommend to add an NVMe SSD since we are running an SQLite database for all of our service. That's fine. Then here, okay. Now it will create a droplet here. So while it's creating, sorry, that's the old one. Let's see, where's the droplet? Okay. Is the one? Yeah, this is one. So the droplet is now created. So what we can do is to set up it with, so first we need to set up with the domain host. So my host is Cloudflare. Go here. Use this one. Then go with the DNS. And let's add another one. Let's do the root path. Then the IP address. So we need the IP address here. Then save. I think Kamal does not work with the proxy, so let's just save it here. And then so this is specific for sorry. Okay. So so this is specific for Cloudflare. You also need to set up the encryption mode to full or the full strict here. If not, the Kamal server will not go through the proxy. So for now, let's just copy this one and then update the script. So for Kamal, we just need to update the IP address here. Let's just do all of them here. And then, of course, the host. And Shiba. And I think that's basically it. So we just need to commit it right now. Work in progress. Then Kamal setup, and this will automatically set up the server to run the Rails app. So it will create a Docker container here. It's pulling the Docker script.
Where does it push the image, the Docker image, to which registry?
Yeah, so it's so by default it will run it in the Docker Hub uh, page here. But the problem is it only has like one private like repo. So
Yeah.
you can only push a one private repository here. And just a note, by default, Docker Hub will push your container as public. So it's very important to um, update the settings for that. Here, you can see, so by default, it will only, it will push it in public. So you need to add in the private setting.
Where did you set up the Docker registry? In which configuration?
Okay, sorry. So it's in deploy here. So basically, it by default it will push to
Oh,
Docker Hub. So you just need the username and password with the Docker registry. You can also use other service like Google Registry and AWS.
I think you can open source a registry in your server. You can open your own registry server
Except for in GitHub.
in your SSH in your server that you created.
I'm not sure with the yeah.
I think there's an open source one that you could. So it's private, but
So right now it's installing the app in the server. So
While we're waiting for that, Jasper said he thought it looked interesting and that it looks easy. Do you find it easy? Like, how do you find working with Kamal compared to other what you were doing before?
yeah, so for Kamal, just need the deploy script and it will run in server. But if you're gonna use it in production, I recommend to skim through all of the docs first before using it, because there's some like uh, put guns that you're gonna encounter. For example, the Docker thing. So it's in the documentation, but it's hidden in the deployment part. And then also there's some issues with the styling. So yeah.
how do you configure the server? Like adding rate limit in the server itself, like security configuration.
I haven't explored that, but I think it's part of the Kamal proxy. So Kamal has the gem. Sorry, it's not a gem. It's a proxy. So they create their own proxy. It's called Kamal proxy here. So I think you can configure. You can configure it to run the rate limits here. So yeah, so it's installing. It's just waiting for it to respond.
And you can add like subdomains, configure it in Kamal.
Yes. So you can add like multiple subdomains and also to a same server with Kamal. So it should work. Siba na tayo. Oh, okay. Yeah. That's the Kamal, so it will automatically install it. As you can see here, that's the TLS script.
Nice.
Okay, just one more. I think it doesn't have the seed, so let's run it. Kamal at but the and just do let's do this. So it's kind of like Heroku, where it has like this default
You can
script.
get at the command line. That's
Yeah.
one thing I launch my stuff via Google Cloud Run, but I can't get at the command line. I can't get at the console from in my production apps, which is one drawback of that. Otherwise, it's all I'm quite happy with it, but that's one big drawback is no console.
Yeah, so we can see the live logs here if we sign up demo at example, then word. Okay, that's it for the configuration. Then for the let's try one code. So it will be processed in solid queue. So here, as you can see, it has 295 and still processing. I forgot the server IP here, so it's not running the LLM. Yeah, it's an easy fix. So can just add in the job. Uh, this one. Then let's just copy the LLM IP. So this one. Okay. And then that's it. Then let's just commit it. Then we can deploy another update by Kamal deploy.
So you publish it to your remote repository, and then Kamal pulls it from the remote to update, right?
I think you can add it. You can just do local update. But yeah, you should for production. You should pull the remote repository.
Mm.
It will just run it again, and it should update the app. So as you can see, it's building the Docker file. So for the Docker file, it's also included with Rails. So it's just configuring the Rails server here. The compilation stuff here. Then it will run the Truster. It's the Rails server here. So if you have some configuration with your assets, you can also add it in this Docker file. And so it will just run it again. Yeah, other than that, let's see. Just configuring it. This is just pinging the server. I think it's back. Let's try again. So let's try an image that is not part of the training data set. So this is I uploaded it um, yesterday, so it should not be in the receipts. So let's just upload it, then add it here. It will be processed. Okay. As you can see, the amount is 430. And then the LLM correctly captured the amount. Yeah, so that's the full demo. So if you have any questions,
Yeah. How do you train if your receipts has a washout? Like doesn't have the subtotal, it just have the list of items. Does it total the items and give you the subtotal? How do you fine tune that in the
so that's a good question. So for that, I think you should just extract the line items, the per line um, extraction, and then the LLM can add those line items.
do you need to train that like the one you did?
Yes.
Yeah.
So you just update the annotations. Let's go back to sorry, receivable LLM. So for that, I think we can just add here the annotations. So instead of total here, you can maybe add response and could be valid JSON. So response, then add here, for example, line items.
Yeah.
Then yeah, so just add the line items, the name, and yeah, the amount. Yeah, I think the LLM can process that as well. And for that, I also recommend to use like a stronger model to create those annotations. So you can have like faster creation of training data set. Yes, that's pretty much it. Do you guys have any questions?
Do you see that as something that you would consider putting out as like a resource? Either your fine-tuned model or the deployed instance or anything like that?
Yeah, sure. So actually, the fine-tuned model is in public. The GUF format here is the public. Yeah, so it's public model, and you can run it in locally. So for example, here in add it in LM Studio. Yeah, it's public. You can use it if you want.
Cool.
Yeah, so that's pretty much it. So that's the full deployment. So from fine tuning to deployment here. So yep. Thank you.
You can fine tune yourself, like how you talk. What's your personality?
Are you going to keep developing it, or you just did this for practice and you're kind of done now?
I'm planning like a different app for the receivable.io. I think the domain is a good name. So I'm planning to use it for other projects.
Cool.
So
I love Recibo.
so that's just me. Yeah, so that's pretty much it for the presentation. Yeah, again, thank you for the team here and also the participants in this month's
So Ruby on Rails i-run through Docker. Ruby on Rails run on Docker.
Yes.
Sabi niyo kanina yung about sa lang training is, di ba, ang price niya is ganito. Mabilis ba kaya yan? O baka matagal?
Depende kung ano yung model na gagamitin mo.
Well, di ba, nakuha lang niya 30 minutes lang, hindi kalahati lang yung price na babayaran.
Depends on the DPS provider, but I think they just rounded up to 1 hour
1 hour talaga.
usually. Yeah.
What's your motto?
So yeah, this is our team members here. This is Super Ken. Yeah, so I think we're done with the demo.